In section 10.1 and 10.2, we start talking about what happens when we work with triangles that don't have right angles, which means they're called oblique triangles. We won't be able to use SOHCAHTOA. We're going to start using law of sines and law of cosines. Briefly, let me just kind of remind you about naming conventions. The angle is opposite of its corresponding side. So if you're looking at angle beta right here, across from it is side B. So just keep that in mind when you are drawing triangles or solving problems. It's always across, and then the letters are the same. Okay. The angles will be alpha, beta, gamma, or ABC capital letters, whereas the sides are always lowercase. And we've talked about that with SOHCAHTOA, I think, and this is just kind of a quick reminder of that. So you may have seen law of sines and law of cosines before. Law of sines is a bunch of ratios. So like sine of angle A over side A is this equal to sine of angle B over side B is equal to sine of angle C over side C. So that's one that I think you should be familiar with. Whereas law of cosines looks a little bit trickier. Okay. And the way that I like to think about law of cosines is whatever you're looking for is going to be on the end of the equation. So in the first one that I've just highlighted, we're going to be looking for something related to C, whether it's C or gamma. That's what we're going to be solving for. Here, we're going to solve for B or beta. Lowercase b or beta. And then in the last one, we're going to look for A or alpha. So if you struggle to remember these, just keep in mind that whatever is on the ends is what you would be solving for, one of those two. Both of these laws are always true, but each problem is different. So you always want to draw a picture. The issue is you don't always know which law you need to use. So here's some little things that you might be able to do to help you. First, look at the information that you have. So what info do I have? Okay. If you're using law of sines, the information that you have is two pairs. You have two pairs of data or info, two pairs of letters. So, for example, you might have little a, capital B, A, wow, little a, capital B, and you need little b. That would be two pairs. You have A and B, so you'd use law of sines. If you're using law of cosine, you need one of each letter. So you have one of each letter. And the options are you have all three sides, or you have two sides and an angle. An angle. So those are kind of your options. So either you have all three sides provided to you, A, B, C, or you have, let's say, A, B, and angle C. So those would be the two scenarios where you're using law of cosines, but you basically have one of each letter and no more than one angle. If you have multiple angles, chances are you're going to use law of sine. Let's go ahead and do the very first example based on this figure. Let's find the distance between the top floors of the two buildings, which means we want this distance. Okay, this is the unknown. We're just going to call it C, right? It really doesn't matter what we call it. We just have to make sure we're using the right equation. Based on what I'm seeing, I have a side, angle, side. So I'm going to use law of cosines. So we have C squared equals 370 squared plus 350 squared minus 2 times 370 times 350 times cosine of 2.1. Notice we're in degrees, so make sure your calculator is in degrees. We're going to get C squared is equal to 573.946, and it keeps going. So if we want C, we need to take the square root of that number. I'm just going to copy and paste. So C is going to equal 23.96 kilometers. Now, the nice thing with this question is everything in here can go in the calculator in one go. You do not need to split it up. Save yourself the time and energy and put it all in the calculator at one time. Let's look at the next example. Assume that angle A is opposite angle A, side A, all that stuff. Solve for all parts of the triangle given this information. So we've got a capital A, a capital C, and a lowercase b. So it looks like we have one of each letter, but we have two angles, which means we're not going to use law of cosines. I can find my third angle because I know that all the angles add up to 180. So angle B is going to be 180 minus the angles that I already have. So angle B is going to be 89 degrees. Now I have B and B. So I have a full set of B and I can find A or C. It doesn't matter which one I start with. I'm going to have to find both anyway. Let's just go ahead and do, we'll just go ahead and do A. So for law of sines, we're going to find A. We have sine of angle A, which is 36, over the unknown side equals sine of 89 over side B, which is 7. We'll cross multiply. And then we'll divide by sine of 89. If I write it, 7 sine 36 over sine 89. This just goes in the calculator. So in the calculator, make sure you close these parentheses. A is going to be 4.12. I don't think we had units. We did not. So units or nothing at all is fine. Then let's go ahead and do the same thing, but now we need to find little c. So we want to use this information again because we already had it to work with. And now we'll just set it equal to sine of 55 over little c. We cross multiply again, and we have c equals 7 sine 55 over sine 89. And c is going to equal 5.73. So everything that we needed was angle B, little a, and little c, and we found all three. I'll go and box this as well. Okay, next one. So we have gamma is 44.4 degrees, little a, and little b. So that means we're using law of cosines. So this is going to be on the end, which means we are looking for c squared again. So we have 2.56 squared plus 3.32 squared minus 2 times our sides times our cosine of gamma, which is 44.4 degrees. Remember, we're in degrees right now. Make sure your calculator is in degrees. So that's going to be a total of 5.4311. But we don't want c squared, we want c. So let's take the square root. and C is going to equal 2.33. The good news with law of cosine is that you're only going to use it once in a problem, because once you have a pair, you can automatically switch to law of sine. So now we have a full pair. We have C. So we can do law of sine to find everything else. So now I have sine of gamma, which is 44.4 over the side that I just found, equals either A or B, it doesn't matter. Let's go ahead and do A. So sine of A over 2.56. Okay, we're going to cross multiply and we're going to have sine of A equals 2.56 sine 44.4 divided by 2.33. Now we want angle A, not sine of A. So remember, we're going to find the inverse, which we covered way back in one of the first chapters of this expression. The answer to that is going to be 50.23 degrees. Oops, that should be A. Now we have two angles out of the three. So to find the last one, we can subtract everything from 180. So 180 minus the one we just found, 50.23, minus gamma is going to be 35.14 degrees. And that's angle B. Okay, one more. We have little a, little b, and capital B, which means we're going to use law of sines again. Let's plug it in. So we've got sine of 121 over 27 equals sine of a over 5. Let's cross multiply and then divide by 27. Remember, we need to do an inverse if we want the angle measurement. Sine 121 over 27, and angle A is going to equal 9.13 degrees. And now we have two of the three angles, so we can go ahead and find angle C, which is 180, minus the angle we just found, minus the angle that was given. And angle C is going to equal 49.8 degrees. Now that we have angle C, we can do law of sines one more time to find little c. So let's start with sine of 121 over 27, which is what we were provided at the beginning. We just found 49.87, and we're going to divide that by our unknown side. And now we're going to cross multiply and solve. 27 sine 49.87 divided by sine of 121. C is going to be 24.08. I would encourage you to do the next one on your own. And then if you get stuck, come back to the video. So we have two angles and a side. We can find the third one. Okay. And then we have all of our angles and can just use law of sine. So angle B is going to be 180 minus 70 minus 68. So angle B is going to equal 42 degrees. So now, doesn't matter where we start. We could just start with C since C was given. We'll have sine of the angle 70 over its corresponding side, 3.75, equals sine of 68 over little c. Cross multiply and solve. C equals 3.75 sine 68 over sine of 70. And C is going to be 3.7 kilometers. And then we'll do the same thing for B. So we just need to repeat this part and then write out the information for B. So sine of 42 over little b, cross multiply and solve. 3.75 sine of 42 divided by sine of 70. B is going to be 2.67 kilometers. Now we run into the ambiguous case. We call it SSA because if you spell ASS, it spells a bad word, and we don't do that in math, I guess. So if this happens, there are two potential triangles or as little as one triangle. So it's a little bit messier. This generally I don't put on the exam, but I want you to have seen it. So I'm going to do an example where it's going to show you how you end up with two triangles. So if you have two triangles, it's because um, angle B ends up being bigger than angle A, where angle A is the one that was provided to you. Okay. So we have a law of sines situation. I'm going to go ahead and do law of sines. So we have sine of 20.5 over 12 equals sine of b over 31. So sine of b is going to be 31 sine 20.5 divided by 12, and angle b is going to be sine inverse of that. So what we get is angle b is equal to 64.78. That is bigger than the given angle from earlier. I'm going to write that in red. This is larger than A, which means there can be a second triangle. Okay. I'm going to just keep solving this one, and then we'll solve the second triangle. So I'm going to say two triangles. From here, I can find angle C for this triangle is 180 minus 64.78 minus 20.5. And angle C is going to be 94.72 degrees. Now I just need to do law of sines one more time to find little c. So we have sine of 94.72 over little c equals what we were originally given with, sine of 20.5 divided by 12. C equals 12 sine 94.72 over sine 20.5, which is going to be 34.15. I think it was meters. Okay, I'm going to shrink that down a little bit. So this is the first triangle. So triangle 1. Triangle 2 is going to be based off of what happened here. We can find the second triangle by saying 180 minus the first angle we found, 64.78. This would be 115.22. So here is the other option for angle B, which does then affect what C is going to be. It does affect what C is going to be. So angle C is then 180 minus 20.5 minus 115.22. I need to do the math on that really quick. I hadn't written that down earlier. 20.5 minus 1.2, 44.28, which is different than the first angle C. So now we can just do sine of 44.28 over little c equals sine of 20.5 over 12 and cross multiply and solve. And we are going to get C is 23.92 meters. All right. Then there's a situation where if you have all three sides and you need to find the angle first, find the largest angle first. So keep in mind that inverse functions have restricted ranges. And so cosine has a restricted range in quadrants 1 and 2. Sine is negative pi over 2 to positive pi over 2. So quadrant 4 and quadrant 1, but keep in mind it's negative. And inverse cosine is the only function that's going to have an obtuse angle. So you want to find the largest angle first, because then you can actually figure out that it's obtuse. So to figure out which one is going to be the largest angle, look for the largest side. The largest side is going to yield the largest angle. The largest side yields largest angle. So this part, I'm actually going to pull up the calculator because it's a little bit trickier for when we get there. So we have c squared, and we want to set that equal. So 54 squared equals 41 squared plus 18.5 squared minus 2 times 41 times 18.5 times cosine of big C. Now we need to just start combining like terms. So we are going to combine this, we'll combine this. So 41 squared plus 18.5 squared is 2023.25 minus 2 times 41 times 18.5 is 1517 cosine of C. 54 squared is 2916. So we need to start getting cosine of C on its own. So I'll go ahead and bring this over by subtracting. So 2916 minus 2023 point answer minus 2023.25. So that's going to be 892.75 equals negative 1517 cosine of C. So now I'm going to divide by 15, negative 1517. So I have cosine of C equals, and I'm going to leave it as this and not simplify. And remember, to find C, we want to do cosine inverse of this whole expression. That means C, remember here its second cosine is going to be this number divided by negative 1517. Okay, it's going to be roughly 126.1 degrees. Come on, there we go. From there, you have enough to do law of sines. I'm going to stop there because we've done plenty of law of sines examples. But after that, you can find angle B and angle A. Let's briefly talk about this equation to find area. It is 1/2 AB times sine of theta. And theta is determined by having an angle in between sides A and B. So find the area of a triangle with sides A of 4 kilometers and B of 15 kilometers. That creates an angle of 45 degrees. So that's like A, B, and here's theta in between. It's a really straightforward equation. Area of the triangle is 1/2 times 4 times 15 times sine of 45. And if you get an approximated value, that's 21.21 kilometers squared. Don't forget, area is squared. Finally, we also have Heron's formula, where we have this letter S, and S is all the sides added up together divided by 2. So this is a little bit different than something you've probably seen before, but we can easily calculate it. So we would have S equals all of these added together divided by 2. 1.4 plus 2.3 plus 3.2, and S is going to equal 3.4. Now that we have S, we can plug it into this equation. So the area of the triangle is equal to 3.45 times 3.45 minus the first side, 3.45 minus the second side, and 3.45 minus the third side. And that's going to be 1.426 yards squared.